Hey class, today we're going to talk about valence electrons. Remember, valence electrons are the electrons in the outermost energy level. And basically valence electrons kind of determine whether or not the atom is going to bond with another atom. Chemical bonds are formed by, you should already know, electrons being shared, gained, or lost. So let's look at this oxygen atom right here. We know it is atomic number 8, so it has 8 protons, 8 neutrons, atomic mass 16. On the first energy level, we can hold up to 2. The second energy level, we can hold up to 8. And the third energy level, we can hold up to 8. This should already be a review. But valence electrons are the electrons in the outermost energy level. So we can count here 1, 2, 3, 4, 5, 6. So the valence for oxygen is 6. Let's go on to another one. Aluminum. All right, so aluminum is 13 protons, 13 neutrons, 2 electrons in the first energy level, 8 electrons in the second energy level, and 3 in the third energy level. So the valence are 3. Now I have these words here: give, take, or share. And what do these mean? Well, we got to know whether or not aluminum, when it wants to bond, is either going to give away electrons, take in electrons, or share electrons. And basically, we want to fill the outermost energy level. Now, obviously, it has 3. We can just add 5 and fill it up. If we added 5, it would be taking electrons from another atom to fill up the third energy level. An atom that has fewer than 8 valence electrons is much more likely to form bonds than an atom with 8 valence electrons. Atoms like to be happy, meaning they like their energy levels to be full. Now, full, we know, is 8 on the outside for the third one, 8 for the second one, and 2 for the inside. And when these are full, atoms are usually happy. They usually don't like to give away electrons if they don't have to. So we already know atoms bond by gaining, losing, or sharing electrons in order to have the filled outer energy level. So if we look here, we can add 5 to get 8, or we can lose this one, and this one, which would drop our valence down to the second energy level and give us 8 valence. Remember, we want to be full. The atom wants to be full. It wants to have 8. So what would be easier, losing 3 or adding 5? Well, usually losing 3 would be a lot easier than adding 5. So we would assume that aluminum is going to give away 3 electrons. Give away 3 electrons. Moving on to sodium, okay? It has 1 valence. We can see in the third energy level, 1 valence. Now, it wants to have 8 valence electrons. What would be easier for it to do? Give away that 1, so we can drop down to the second energy level, or add 7 to the third energy level. What is easier? Give away 1 or add 7? Probably give away 1. So it probably just is going to give away this 1. Or maybe it'll find something that has 7 valence, such as chlorine. Chlorine has 7 valence. So a sodium needs 7, and a chlorine needs 1 because it has 7 valence. So maybe they'll share. Lithium. Okay, what would lithium do? We see there's 1 valence. Again, 1 valence. Should it just give it away? And then it would have 2. Or should it add 7 in here? Probably just give away this 1, like I said. But is 2 electrons a full set? Well, not all atoms need 8 valence electrons to have a filled outermost energy level. Helium atoms, atomic number 2, only needs 2 to fill up its outermost energy level. Remember, the first energy level can only hold up to 2. So 2 on the inside, the first energy level would be a full set. The outermost energy level of helium is the first energy level. The first energy level of any atom can hold only 2 electrons, like we already talked about. So if we give this one away, then the outermost energy level is now the first energy level in 2, and that would be a complete set. Remember, the electrons, they want to be happy. They want to make a complete set. They want to fill up an entire energy level. And once they do that, they're generally happy, and they usually stop doing what they're doing. We can see we gave away this one. We have now dropped down to 2 valence, and this would be a happy atom, or a full atom, as we could say. All right, this is what I want you to do. Tomorrow in class, we're going to work on some problems with valence, figuring out the number of valence, whether it's going to give, take, or share electrons. I want you to look at the periodic table that I gave you and look at this one. We can see the columns, 1, 2, all the way up until 16, 17, 18. So we have 18 columns. I want you to come in tomorrow to class and tell me what is so unique about these in relation to the number of column that they're in. These elements in relation to the number column that they're in. These. There's something special about this number up here that will tell you something about their valence. Okay? I'm not going to tell you what it is. I want you to figure it out tonight. Come in and tell me tomorrow. It'll make things a lot easier for you when we move on. So something about these numbers up here will tell you something about the elements that they're in relation to the valence. So again, to recap, valence electrons, the electrons in the outermost energy level. An atom wants to have 8 valence electrons, or it wants to have 2 on that inside ring. It wants to be happy. It wants to be full. So it's going to do whatever it has to do to get extra electrons or to get rid of some electrons in order to make it a full set. All right? So I'll see you tomorrow. Have a good night.